Good evening. Welcome to the video lecture on the topic Elements of Digital Communication Systems, which is a part of a series of video lectures on digital communications. And this is Jai Krishna, currently with Vidyaniketan Engineering College, Tirupati. So this is the block diagram of digital communication system. The first block in the digital communication system is source. This source can be an analog source or a discrete source. A discrete source generates a discrete set of information, whereas analog source will generate analog information. So if we assume this source to be a discrete source, then automatically it will give discrete information. But if we assume this source to be analog, we have to assume that the analog signal will be converted into discrete signal, and discrete set of values will be given at the outcome of the source. So here I have shown A, B and so on as the discrete information that was generated by the source. And the source encoder, so the source actually what we generated so far from the source is just a discrete levels. So we have to convert it into binary by assigning different binary sequence to each and every discrete information. So here we are converting A into 1001101, B into 11001001. Likewise, we are going to assign different code, different binary sequence to each and every discrete information that was generated by the source. And so here we can understand that source encoder is converting or assigning binary sequence to different discrete information that was generated by the discrete source. And coming to the channel encoder, the channel encoder adds few parity bits, so that if there is any error in the channel, that can be detected as well as corrected. So here in our example, 2 bits are added to each sequence of binary numbers, so resulting more number of bits in the code word compared to the original bit stream, but still it is required to detect the errors as well as correct the errors. So the task of channel encoder is to incorporate error detection and error correction techniques. Coming to the modulator, so far what we got is we have received a binary sequence, and usually the same voice information in different applications need to be dumped onto different frequency spectra. So that can only be done by using a sinusoidal carrier to incorporate frequency translation. So what we do is we are going to perform modulation by using a sinusoidal signals, and there are different digital modulation schemes, and I have shown one of them. So here one is modulated, or one is represented using high frequency sinusoidal part, as well as 0 is represented with low frequency sinusoidal part. And transmitting antenna transmits this signal, and in the channel there will be some noise which will corrupt or which will disturb the original information, and the receiving antenna receives the sinusoidal signal and gives to demodulator. Demodulator converts it into binary sequence, and channel decoder will remove the parity bits which we have added at the channel encoder, and the resultant bits will be given to source decoder. Source decoder extracts by discrete levels from these binary sequences. And source encoding, so as I told you, the discrete source generates discrete set of information, something like A, B, C and so on. So let's assume that we have 8 different discrete levels. We may use binary numbers with length 3. So 000 to represent A, 001 to represent B and so on. So this will be done by source encoder, and binary sequence is a simple source encoding technique, but we can use less number of bits as in total by using different source coding techniques. This includes arithmetic code, Huffman code, Shannon codes. And channel encoding or channel coding techniques, so which are used for error correction and error detection correction. They are block codes, convolutional codes, cyclic codes, turbo codes and many other. And modulation schemes, digital modulation schemes involves ASK, PSK, FSK and so on. Thank you.